Hey everyone, my name is Julian Miller, and in this video we're going to be covering polymorphism in C++. So the word polymorphism is actually the combination of two Greek words. The first word is poly, meaning many, and the second word is morph, meaning form or forms. So when we say something is polymorphic in programming, what we mean is that something exhibits multiple forms or multiple behaviors. Think of it this way. If you were to press your computer's power button right now, your computer would turn off. If you were to press it again, your computer would turn back on. So even though your computer's power button doesn't look like it's changed at all, it actually has two different forms or behaviors. We're going to use shapes as an example because shapes are often used in software like computer games for collision detection and rendering, as well as graphical interfaces, so things like buttons and images. And we're going to start by making just a simple class to represent a simple shape, a rectangle. So we'll start by defining our rectangle class. And a rectangle only has two members really, for our purposes. It's going to have a width and it's going to have a height. Likewise, we're going to give it a constructor that accepts a width and it also accepts a height. And I'm going to go ahead and just define everything in one file. This isn't necessarily best practice, but I want to keep things short and to the point. So as an exercise on your own, you might want to consider splitting this up into its own header and implementation file. Great. So there's a constructor. And to make things a little more interesting, we're going to give it a function to get the area. And to get the area of a rectangle, all you need to do is multiply the width by the height. Perfect. Next, we're going to make a main function to test out the class we just made. So all we're going to do is instantiate a rectangle. We're going to give it a width of 2 and a height of 6. And we'll just output the area. Awesome. And we'll need to include IO stream for cout and end line. And we can run it. Awesome. So the area is 12, which is what we expect because what we're doing is multiplying 2 by 6. Now let's say we wanted to do the same thing with a circle. So we'll make a circle class, and instead of a width and a height, we'll give it a radius. And we'll give it a public constructor, just like our rectangle, and a getArea method. And to get the area of a circle, we just want to multiply pi, which is 3.14159, times the radius squared, which is radius times radius. Our circle and rectangle both have getArea methods, so let's make a common base class to share between them. We'll call it a shape, and we'll give it our getArea method. And we'll make our getArea method pure virtual by setting equal to 0, meaning that it will force us to implement it in all of our subclasses. This is where polymorphism comes in. And in C++, it only works with pointers and references. So let's make a reference to a shape. And we'll make it refer to our rectangle. Now, instead of getting the area of our rectangle, we can get the area of our shape, which is actually set to our rectangle, and run this. The reason it works like this is because our shape variable actually has two different types. It has a static type of shape and a dynamic type of rectangle. And generally you can only do this when the dynamic type is a subclass of the static type. The downside to using a reference is that we can't tell our shape to refer to something else after we have already defined it. So let's change this to a pointer. And let's try telling it to point to a circle. So we'll make a circle, we'll give it a radius of 5, and we'll tell our shape to point to the address of our circle. And then we'll try outputting the area again. So you can see that the first call is to our rectangle's area, and then the second one is to our circle. So you can see why this is called polymorphism, because our shape variable has multiple behaviors depending on its dynamic type. This also works for function arguments. So let's say we wanted to move our output here into its own function. We'll call this print area. And remember that polymorphism only works with pointers and references, so we'll accept a reference to a shape. And I'll put our output in here and change this back to the dot operator because we're no longer dealing with a pointer. And we should be able to call print area on both our rectangle and our circle, as well as our shape. Remember to dereference it because our shape is still a pointer. So again, it is printing our rectangle's area first, our circle's area next, and the circle area again because we are telling our shape to point to our circle. This is really nice because it lets us reuse the same code for multiple different types of objects, as long as those objects inherit from the static type. You can also do more complex things with lists or collections of polymorphic objects, and even more, like dynamically loading libraries from a file. But overall, this sums up the basics of polymorphism in C++, and I hope you enjoyed it and learned something. Definitely let me know if you have any questions or comments or suggestions. Thanks for watching.